Hi, and welcome back to another episode of Semmelweis STEMtalk. Today, I'm delighted to welcome Dr. Eszter Novák-Gselmann, who is an associate professor at the Institute of Mathematics at the University of Debrecen. Her work focuses on functional equations, mathematical analysis, and mathematical psychology, fields that connect deep theoretical thinking with meaningful real-world applications. Beyond research, she's also a dedicated mentor and educator, an active member of the Hungarian scientific community, and a mom. And her work has been recognized with multiple awards over the years. Thank you so very much for joining us today. And let's kick this episode off by telling our guests a little bit about your story that led you into science.
First of all, thank you very much, Victoria, for the kind invitation. I'm happy that I'm here. The story for me, for being a mathematician is rather simple, but I won't say that it was exactly straightforward. Mm-hmm. But it became quite clear quite early for me that I passionately loved mathematics. But besides mathematics, I also liked physics and chemistry in the primary school. And the reason why I loved this subject was that I was admired by the fact that with the aid of physics, for example, physics and chemistry, the world around us can be described and can be understood. Mm-hmm. Later on, when in the high school, I realized how much mathematics is embedded into these disciplines, but at that time it was not clear for me that I would like to become a mathematician. In fact, I don't even know that this is possible. Uh-huh. I always thought that being a mathematician is something like as being a writer. Mm-hmm. It is a job for which it's not possible to study for, but after that you make some efforts and some valuable things. The community will recognize you, and after that you became a writer, or in my case a mathematician. It was by chance that I realized that it is possible to learn mathematics at the university. I asked my math teacher for advice, and he encouraged me to apply, and that's how I became a mathematician. And after that, my university professors had a great impact on me when I finally chose the academic path. Mm-hmm. So this is basically.
And in simple terms, if it's even possible to do it in simple terms. So in simple terms, what is your work about? Because I think a lot of people probably, when they hear mathematics, they have flashbacks to their high school maths classes or something, and then they get a little bit scared and uncomfortable, anxious. Yes, they have a bit of anxiety and sweating. What is it that you have to do?
I would answer a rather different question, but I feel, or I hope that in some sense it will connect to your question. For me, mathematics is nothing but a language which helps us to understand the world around us. So that's why I was always admired by in some sense, the power of mathematics. In my research, I'm interested in functional equations. People, I guess, everybody met equations, with equations in the school. Mm-hmm. But I'm interested in functional equations. In this setup, the unknown is not a number, but a function. They typically come into the picture when we would like to understand a process, and the process typically can be described not via a single number, but a function, how the process evolves itself. And functional equations come into the picture when we would like to set up a model. And this model can be written down with some rigorous mathematics. Mm-hmm. And after that, these equations can be solved, and the solutions after that can be reinterpreted in the setup where they stem on. I'm basically currently interested in the applications of functional equations in psychology, especially in psychophysics. Psychophysics is a branch of psychology, and typically the aim is to understand the relationship between physical stimuli mm-hmm. and perceptions, and between perceptions they produce. We would like to understand how from a measurable, from a concrete physical quantity, our brain or the central neutral system produces a sensation. Mm-hmm. And this can be modeled via functional equations that can be, in some cases, solved. And in such a way, we understand this process. For example, we would like to understand that if we see, if we hear, for example, different sounds, then how can we make difference between these sounds and so on?
That's very interesting. I've never heard about these fields before. It amazes me how different sciences and different aspects of life are connected. Mm-hmm. And in fact, mathematics is a part of all of it, really, at the end of the day, yes. It seems. When we talk about, research, I think a lot of people have this idea of what is a scientist? What do they do? Somebody in a lab coat, somewhere in a lab with a pipette, maybe doing some kind of experiments, maybe some cell lines and something. When we're talking about mathematical research, what does that look like? What is the process?
In some sense, I would say, if I would be really strict, that mathematics is completely different. Because it is a quiet job. Mathematicians typically sit at a table and they are simply thinking, mm-hmm. sometimes writing. So yes. If I would simplify the things, pure mathematics is rather a pen and paper research. But this is not always the case. The other difference compared, for example, to experimental research is that we work typically alone. So this is a solitary work. But of course, working in the research group is always motivating. Mm-hmm. But we are typically not thinking together. Right. We are sharing ideas. We are reading others' ideas. We are inspired by others' results. So I would say that it is a much more quieter and much yes. more solitary work than in case of other disciplines.
And what does your typical day look like, if there is such a thing?
Typically, I prefer start the day early in the morning. Mm-hmm. Around 5 o'clock,
oh my goodness me! I'm the complete opposite.
There were years in my life when my daughter was much smaller than when I started the day at 4.
Oh my God! So, wow, you're a hero.
So I prepare the necessary things for my family in the morning. Mm-hmm. In fact, one reason why I like to get up early is to have my coffee in a relaxed way. So mm-hmm. I drink my coffee. Nobody should say nothing to me. I would like to be alone. Mm-hmm. But after drinking my coffee, I try to concentrate on my family, what they have to do, what they need from me. I typically work at the institute. Mm-hmm. It is although possible for me to work from my home, but I prefer work there because I'm entering some kind of scientific atmosphere. So
Right.
when I'm home, of course it is also possible, but typically when I work from home, I always have in mind, there is, our home is so messy, so
there's always something to do, yeah.
Yes.
That looks like I need to fix it, or this and that.
But so I would say I prefer to work at the institute because there I can be focused, and being focused is indeed a key property when you would like to do mathematics. So typically I arrived at the institute at 8 o'clock. I have also university courses. I have students as well. I have a PhD student. The majority of my day is devoted to teaching and mentoring, and of course to research. Now, when we have the examination periods, at least now I don't have teaching duties, so I can focus more on research. Besides this, I was always interested in mentorship, in advocacy. I always was interested in how the career of women scientists can be made easier, or how women could be mentored. And to answer your question, yes. I typically work until 4 o'clock in the evening. After that, sometime previously I picked my daughter from the school, but now she wants to be independent, so we meet at home. And until she goes to sleep, all my time is and attention is for her. So I concentrate on my family until they do not get into the bed. It might happen in some cases that after that I should work, because advocacy cannot always be made during the working hours.
Of course.
Or in some cases it might happen that my PhD student needs more time and more attention from my side. So that's why I have to work during the nights as well.
I see. And what would you say are some of the unique challenges of the field of mathematical research?
Mathematics needs indeed a lot of patience and persistence. Again, now I know that I'm simplifying things, but compared to experimental research is when you start an experiments, you make measurements and so on. After that, the experiment, there will be something. Every real experiment has a result. In mathematics, this is not the case. So it is always we work on a problem, and it might happen that we try to solve that problem with several methods, and no results appear. It can take weeks or in some cases months that you work, and there will be no result. It is indeed quite hard. So I would say that mathematics needs persistence indeed. But from the other hand, mathematics. So doing mathematics, you do not need basically anything, not even a pen or a paper, just your thought. So it can be done everywhere, and the language of mathematics is universal. When I say in Hungarian that we have let's say a differentiable function, then this means exactly the same in the United States of America, in Australia, in Africa, right, everywhere, every time. So it is a universal thing, and this is an exact thing. That's why I love mathematics. The other things, that I think in mathematics, but I would say this is true in case of any other disciplines. You have to be open for new areas, new ideas, new problems, and you have to also be open for the possibilities, to the opportunities. Mm-hmm. I think that it is a great problem which I see among the PhD students, that they believe that they have a research field or a research problem. Mm-hmm. This is not the case. They have some research fields. So, but I always emphasize them that they have to be open, because if you are interested in a problem, and this is not a forced thing that, okay, now you are my PhD student and you are forced to solve this problem, but you have the feeling that you can choose from topics, then I think that you will be much more motivated. And if you are motivated, then I feel that problems are much more solvable or much more easier if you have motivation.
You mentioned that you also teach university courses, right? It's also, I suppose, mathematics related courses. I can imagine that the concepts that you have to teach can be complex at times.
Yes.
What was it like for you to get into teaching these complex concepts? What did this experience teach you? How to adapt these concepts into a format that is understandable to somebody who's new to it?
Interestingly, imagine that typically I do not teach mathematics for mathematics students, but I rather teach mathematics for students in computer science, engineering, and physics. So although you might think that computer science or engineering is closely related to mathematics, but my students typically don't like mathematics. Or I would say they think that they do not like mathematics. And it is quite important that I realize that during my teaching activity, I should teach mathematics for those who don't like mathematics. And that's why I had to adopt other techniques how to solve them. And the other thing is that I also emphasize for my students at the universities the sentence I said at the beginning of this conversation, that for me and for them also, mathematics should be a language. And when you learn mathematics, you learn, in fact, problem-solving strategies. So I think that learning mathematics is of course useful for its own, but learning mathematics can be quite useful because you learn problem-solving strategies, and it can be useful for in your life or in your work. For example, I typically teach my students the following: if you see a problem which seems hard, then typically every hard problem can be in some sense cut into several smaller but manageable problems. And if you solve the manageable problems, then finally you can solve the original hard problem. In fact, this is the case when you think about computer science. Every long piece of code consists of smaller codes. So this is the phenomenon then that my students, for example, in computer science, should realize that every big problem can be divided into smaller parts that are manageable. The other thing is that in the majority of the cases, the hardest thing is not to solve the problem, but to understand that what the problem really is. I think that this is the case in our everyday life. In the majority of the cases, the solution is easy if you understand what causes the problem. So that's why I emphasize such kind of things for my students, and and of course I must know at every stage during the teaching process that these are students who are not here because of mathematics, but because of they would like to learn something else, and my job is to help them in their own path, not in my path.
I think that's really, really wise what you just mentioned. This whole approach of seeing any big problem as a sum of much, much smaller problems that you can solve. And then at the end, if you tackle each one individually, you solve the big problem. I think that's really great and applicable really to anything in life, I would imagine. And you also mentioned that you don't only teach, you also mentor, right? Besides the teaching. What do you think is the role of mentorship in science, and what role did it play in your own life?
Mentorship played a great impact in my academic career. Of course, at first I was a mentee of someone else, of my senior colleagues. I think this is natural because mentorship is typically done downwards toward the younger generation. So there were several colleagues, basically senior colleagues, who helped me a lot. And I realized that this mentorship means a lot. They give me something really valuable things, namely their time and attention. And this is a gift, which I should, at least as I can, I should somehow give them back. That's why when I was, for example, a PhD student, I made some administrative work instead of my senior colleagues in order to decrease their workload. And after getting the PhD and after starting to work, I felt that this is my duty to help the younger colleagues. So I do not do mentorship in an official way. I just simply do it on my own. But I certainly feel that it is my duty. I see every community to which I belong. It can be the department, the institute, some larger community as an ecosystem. And in my view, this kind of ecosystem can only work if the members of this community put work and time into the system for the others' benefits. So if my idea is that if I put work and time and I do what I can do, then after some time I will again get back something. So this is how it works. Because I think that of course I have some mates when we were PhD students who basically did not have any mentor, and it was indeed hard for them. They survived, and after the PhD, they indeed became, I would say, strong researchers. But I think that the feeling that they did not have mentors in their early career stage had a rather negative impact on their soul, I would say.
Yeah, when you say they survived, it's great. It proves something that you're a strong person. But I think there's a difference between surviving and living and thriving.
Yes, this is the point.
And why do we always have to just survive? Yes. Why can't we live? And why can't we help each other? It's really beautiful what you said, I think, this feeling that when somebody gives you their time, their mentorship, it's a gift. And then you feel like you need to also return the favor both to them and also to the community as well, to your colleagues in the future. And besides mentorship, you also mentioned advocacy. And I know that you are one of the founding members of the Hungarian Young Academy. And I heard about the academy before. That's doing a lot of great things. Now, what did you have to do as part of the advocacy initiatives?
First of all, I would like to start with now I'm only the proud alumni member of Hungarian Young Academy. But as you mentioned, I was one of the founding members of this community. This organization was created to give a voice to young scientists in Hungary, to represent their interest, support their professional development, and of course to foster dialogue between science and society. So as a founding member, basically I had some work in shaping the aims. I also organized of course with my members programs, mentorship programs as well. We wrote several papers on the most problematic fields that in connection with young researchers. I had also other jobs, because being a member of the Hungarian Academy of Sciences is, at least in my perspective, is not only a thing to belong to an elite club, but it means work and desire. So as a member, I had also additional works. I was a member at the Presidential Committee on Science Evaluation of the Hungarian Academy of Sciences, and I was also a co-chair on the thematic mission called Methodology of Science Education of the Academia Europa Budapest Knowledge Hub. Of course, as I said, in some cases they meant indeed a lot of work, but I feel that in such a way I met again extraordinary people with whom I could collaborate, and they gave me the feeling that my opinion matters, and for me it was indeed an extraordinary experience that a senior researcher counts on your opinion. And for me it was really a good thing that I felt that it is having the Hungarian Young Academy is a meaningful thing, so we can do something for the early career researchers. Indeed, we have voice, and they they listen to our voice.
So you are involved in advocacy, mentorship, teaching, research, and also you are a mother. How did having your daughter, change your life and your career trajectory?
I think that if you ask any mother how her life was changed when having children, all of them would say that their life changed a lot. For me, this was indeed the case. When my daughter was born 10 years ago, my life changed completely. First of all, I was on maternity leave for 2 years. It is indeed, I think, long, at least if you work in the academic sphere. But if I had the possibility to do it again, I would decide exactly the same. So it was okay. But after the birth of my daughter, quite complicated for me. Before the birth of my daughter, I would say the sun in my solar system. After the birth of my daughter, I was basically nothing. So I felt that I completely lost control over my life. In fact, it was a good for me, because I learned that not having the control is not a bad thing, because simply I cannot control everything in my life. So I learned from her, from my daughter, that I indeed do not have to control anything, and I don't have to be perfect. It is enough if I'm good enough, from some point of view, from the point of view of our family. And I'm not exceptionally proud for it, but I'm not a perfect mother. I'm not a perfect person, but I would say I'm a perfect mother for my daughter, and for me it's enough. I hope that I'm a perfect, or at least a good wife for my husband, and for me it's enough. For me, my husband is a perfect husband, and this is enough. So I don't have to control anything. The other thing that I learned from my daughter, and this is quite useful in teaching, is that she's a small girl, is only my daughter. She's different from me. She thinks different as me. She likes different things as me. She's an individual, and my job as her mother is to open as many doors as just possible, to let her see the world, to let her see the possibilities. This is my job, to stay behind her.
Would you say it's kind of similar to the work of teaching other people?
Yes, because when I realized that my daughter is not identical with me, of course, now I think that it is obvious. No one knows that his or her child is identical. But although we, in some cases, we force our children to do things, to like things. And this thought was indeed useful for me in teaching, because typically my students do not really like mathematics, and it is okay. Of course, it is always a great pleasure if after a course some of my students becomes to fall in love in mathematics, but it is not obligatory. It is okay if some of them hate mathematics. My job is to teach them something, to guide them through the course.
Right. And is there anything that helps you to manage all of these different responsibilities and your family responsibilities on a day-to-day basis?
For me, the hardest thing is to change between activities. So change between teaching and research, research and family life, family life and advocacy, and so on. For example, when I end one of my courses, it is not possible for me to start research right after. This is the case when I switch between other activities. So I had to develop some simple tricks. One simple trick is that I always ride a bike instead of driving a car or having the public transportation. Because when riding my bike, I can let all the things that connect me to the institute behind. I'm moving, and of course riding a bike needs my attention, but not as many as you ride a car. And I have enough time to change from one activity to the other one. It is indeed hard if I have classes at the university from 8 o'clock, because when I have classes from 8 o'clock, then I start behaving like a teacher around 7 o'clock at the latest.
Right.
So I'm thinking about my course. I'm thinking about what kinds of exercises we will solve, who will be the students that I will ask, how will I react if the group will be tired, how will I react, how the group will be happy and whatsoever. But so I start behaving as a teacher in advance, and it is quite hard because in that time I should take care of my daughter, and she indeed needs my attention, because she exactly has something similar situation. She has to go to the school, and before school, sometimes she just needs to speak things over, why she was sad yesterday, or what she's planning, and so on. So it is hard.
Sometimes it's challenging to be in the moment of what you're supposed to be doing, because the mind is still somewhere else.
One thing that I learned from my daughter when she was small, because small children always live in that moment.
That's right. Yeah.
So it was a great experience, and that's why it was indeed a good decision to be with her for 2 years.
Was it very difficult for you to transition back into the workflow after the maternity leave, or was it a smooth and easy transition?
It was quite hard. So when I was on maternity leave for 2 years, I did nothing in research. So I focused on my daughter. I don't know whether it would have been possible to do some research, but mathematics needs so much focusing, quiet environment that was I felt that it was impossible, and honestly, the real thing that I feel that now it is not the right time for doing research. It is the time for taking care of my daughter. Right. So when I came back to research, or in fact to work, it was quite hard for me, because Hilda, my daughter, was too small. She was sick quite often. Everything was so unpredictable. I felt the pressure that, okay, now I came back to work, now I have to publish papers, but in mathematics, publishing a paper can take several months or years. So the process after submitting the paper is far too long. So what I felt is that now I have to be a researcher, a mother, and a teacher, and a wife at the same time. And I felt that I'm simply unable to be perfect in each of them. But after that, I realized that I don't have to be perfect, any of them. I have to be good enough. And to be good enough depends rather on me or rather on my family than on anybody else.
Right. And is there anything you are particularly proud of in your career?
One thing that I'm proud of, but this is a small thing that I really love my job. This is really what I would like to do, and I'm proud for that. That I do that thing that I indeed like. I like research. I like teaching as well. Mm-hmm. So I think I'm in a good place, and I think that I'm in a good place with good colleagues. This is also important. So I like my colleagues very much as well.
And do you have any regrets about anything?
Yes, unfortunately, I have one thing, and this is again an advice for the younger generation, that I was never a postdoc anywhere. So after getting the PhD degree, we got married with my husband. And after that, in fact, it was 100% emotional decision that we wanted so much a child. Mm-hmm. I was not thinking about how we manage it, mm-hmm. how my academic path will be changed. I would say, passionately wishing for a child. After the birth of my daughter, I went back to work. At that time, she was. I thought that she was small, so that's why I did not apply for any postdoc positions. After that, she started the elementary school. Mm-hmm. Our ideas was she should learn in a Hungarian elementary school. So that's why I did not apply again for any positions. So this is indeed a thing that maybe it would be the best scenario to be a postdoc after the PhD, but this is an opportunity from which I'm over. But hopefully, I will have the possibility to work somewhere else, or at least this means a temporary thing. So I don't wanna move from Hungary for my life. Of course, I think that I'm too old to be a postdoc everywhere because of my age. But maybe there will be some possibilities. But this is a thing indeed which I greatly regret.
Right. Well, one thing that I believe strongly is that you're never too old for anything. And it's never too old to do new things or try new things or to do things that others would not expect you to do at whatever age that they see fit. So I really, really, truly hope that you get an opportunity and that you get to go and that you get to experience
it. You are really kind. I hope too. It's not too late.
I don't think so. I don't think there's such a thing as too late. As long as we're alive, it's not too late. Is there any other advice that you wish to pass on to the next generation?
As I said, this is a general advice, not only for young scientists, but for anybody. I think that a researcher should be open for everything and flexible. From other fields to the other ones. You should be. I think that it is a great thing if you have the ability to work with people from other disciplines. One thing I forgot to mention in connection with the Hungarian Young Academy is that this community is indeed a quite diverse community, and from this diversity, I learned a lot, because in such a way I met several colleagues working in several areas under several circumstances,
right.
and in such a way I had the possibility to understand them. And if you have the possibility to understand other peoples who are in some sense far from you, in such a way you have the possibility to see your situation from another perspective, I guess. And seeing things from different perspectives can mean a lot. If you have the possibility to speak with members from the diverse community, your world becomes much more diverse. And I think that diversity is indeed a value. And one thing which you did not question, but if possible, I would like to tell that being a member of the Hungarian Young Academy means a lot for me personally as well, because being a member, I met there an exceptional person, Katalin Kata Solymosi, a plant biologist. During the joint works, we became friends, and her perspective and guidance, or in simpler terms, her friendship means a lot for me. She's a mother as well, and a great colleague in advocacy as well in science.
Right. I would like to thank you for joining us here today. It was an enormous pleasure to learn about your journey, to hear your point of view on a lot of different things. It was very insightful and very interesting. Thank you so much for taking the time to come all the way from Debrecen to Budapest. We really appreciate your time and your wisdom. Thank you so much.
Thank you very much. It was a pleasure.